Well, thanks everyone. It's great to be here. I'm Dimitrios Pezaros, a professor of computer networks at the University of Glasgow, where we currently, I think, host 5 PETRAS projects. And recently we have been lucky and honored and delighted that my team and I have been awarded a 5-year research chair by the Royal Academy of Engineering, with the generous support of Ministry of Defense, DSTL, and the Control and Instrumentation Nuclear Industry Forum, which is the UK civil nuclear licensees, to look at the topic of digital resilience for critical national infrastructure for the next 5 years. So hopefully, I have to think a little bit on my feet just now, just to make sure I add to what was discussed by the panel and was introduced by Jeremy. But hopefully, I can tell you a little bit about what we plan to do in this program, and some of our background work that hopefully will evolve to some solutions to these challenges we heard in the next 5 years or so. So let's see if my clicker works. So resilience, according to a bunch of definitions, including the one from NCSC, resilience is the ability of a system or an organization to fight back when bad things happen. So in contrast to some of the more traditional cybersecurity definitions that try to prevent bad things from happening, here you acknowledge that bad things will happen, and then what do you do about it? So the critical national infrastructure and the industrial systems that underpin many CNI sectors face a particular challenge that comes from the interface of operational technology, as we heard, which is technology fairly simple that controls physical processes, with technology with generic ICT capability that adds intelligence, if you like, to the whole system and the whole infrastructure. So our systems can be modernized and be made sustainable and so forth by this explicit interface. But at the same time, this means that this, what we call sudden connectivity, increasingly exposes the infrastructure to attacks and adversarial events. And if this clip plays here, this is a clip from an attack on an Iranian steel manufacturing plant last year in June, and you see what happened. So when OT is involved, we're not just talking about loss of data as a consequence, but we can have loss of life when things go wrong. And in this instance, the adversaries not only hijack the plant, they also hijack the IP cameras to make sure that they take a video of what's happening. So protecting such infrastructures is very challenging for many reasons, including technical as well as organizational. We don't have the time to discuss all this explicitly here, but it has to do with how complicated patching of these infrastructures are and the sort of prolonged lifespan of OT devices, to various resource constraints, all the way to security standards and frameworks and guidelines, as we heard before, not really dealing with the sort of more dynamic elements of resilience and focusing more on sort of design time, component properties, and guidelines governing their operation. So what we hope to do in this 5 years program is to look how to assure the evolving behavior of these systems, IT/OT systems, against adversarial events that manifest through the digital, both at their onset, but also over the longer term through profiling the behavior of the infrastructure, and also how to allow retrofitting digital resilience to legacy systems. So we want to devise a holistic approach, like the topic of this session is, or a whole systems approach, if you prefer, based on a framework which the trained eye might see some similarities with various NIST phases. The D square R square plus DR framework that some of us developed and worked on for a number of years for general ICT communications networks, to take this and map 3, if you like, main themes around which our work will concentrate. So one is digital systems. How do we make sure that the required technology for instrumentation and monitoring and control is there to support this infrastructure? The second is data. How can we use data and algorithms to ensure the timely diagnosis of adversarial events? And the third one is people and organizations. How do we integrate technology into the operational environment? So say a little bit about each of these. We're moving to an era where resilience and cybersecurity we're trying to get it built in rather than bolt on. And as we move to environments that are increasingly zero trust, and environments like OT with traditional low network visibility. How do we ensure resilience capability for every element without having to go and instrument every element individually, okay? So we can use the network as a sort of natural aggregator to provide this instrumentation, but this networks is not your typical data center with the resources that you might find. So these networks are resource constrained, and you can think of your industrial Ethernet switches, and there isn't much capability you can add there by default. So I would say that the research challenges here are sort of twofold. If you enable additional functionality, how do you do it at high speeds? And we might not be concerned with multi-gigabit speeds that we are in a data center, but still low gigabit or multi-megabit per second speeds is still tough to add functionality at these speeds. You see, for example, in this figure here, the sort of order of magnitude difference in the performance depending on where you add this functionality in the software stack. And second, how do you develop this software stack to enable this functionality to be extensible? So you can build, if you like, chains of cybersecurity functionality depending on the environment you're installing them at, the types of threats you're trying to protect against, and so forth. And here I'd like to thank the PETRAS Center, because it funded our Trusted project, which looked at some of these aspects, and I think you can see a video of our project upstairs. And also glad that my friend Kate Wells from Censis is here today. Censis supported the building of a board that ensured sort of the trustworthiness of these devices. And when you start developing things for this sort of constrained environments, you kind of hit points where the traditional intuition and assumptions that we make about technology get challenged. So the kind of parallelism that you expect to see in different technologies and the kind of decisions that would improve the performance of a system are challenged and do not hold true. Please go and watch our video upstairs. Now, with data, the question is, what sort of algorithms do we need, and how can we use data to do advanced detection and protection of the infrastructure? And the graphs here show how different types of data, from a simple, EWMA-based algorithm to see load differences and detect faults in the infrastructure, can be useful, all the way down to different types of algorithms to detect denial of service attacks with the same sort of accuracy, but improving an order of magnitude in the speed of detection depending on where you're able to develop these algorithms. And here all the way to a demonstration we had on an operational technology emulated threat model of a naval vessel engine cooling system. And it's a multi-PLC environment that you can attack, and how you can use different states of these environments and some advanced graph properties to graphically represent what is normal behavior and how what anomalies look like when they happen in terms of man-in-the-middle attacks and reconnaissance attacks and so forth. And last but not least is the organizational integration. So I think we've heard quite a bit today about how important the human element is and the organizational element is. And we all know that we, especially as academics, like our technology, but our technology is only as good as much as it can be developed and deployed on real systems. And that means that this technology needs to interface with human operators. It needs to abide by organizational policies and procedures and so forth. So, how, especially as AI ops move from providing advisory all the way to being part of a sort of closed monitoring and control loop, how do we augment the cyber response of organizations, and how do we manage, the sort of sweet spot between automation, complexity, and risk that organizations are willing to take. In that respect, we want to engage the competent authorities that develop frameworks and guidelines, as we heard, for these kinds of systems. and see how more of the dynamic properties and resilience properties of systems can be taken into consideration when developing these guidelines, so that then organizations can protect themselves against. I think with this I'll stop, and I'll thank you very much for your attention, and I'm looking forward to discussing aspects of this that might be of your interest in the breaks and later in the day. Thank you very much.